welcome to lesson 8.6 today. We're still solving quadratic functions. We learned how to solve quadratic functions by what? What was our method? What have we learned so far? Solve quadratic functions by... What have you been doing the last couple of days? By graphing, yeah. And when we solve them by graphing, we're looking for the what? Well, we need A, B, C, but what are we really looking for that we say are the solutions?
The zeros.
The zeros of the function. Are there always two?
No.
No, sometimes there's only one. And actually sometimes there can be zero, but we don't have to deal with when there are zeros. What's that mean for the quadratic function until you're in advanced algebra. So our learning goal today is I can solve quadratic functions by a new method now, and it's by factoring. That's why it was so important that we got a good handle on factoring back in chapter 7, because now we're going to use it for solving. So the zeros of a quadratic function are, what does a zero mean again? The x value where y is equal to what? Zero. So we gotta have that understanding of what is a zero. We can't just say, I gotta find the zeros, but not really know what you're looking for. You're looking for the x value where y is actually equal to 0. When you find the zeros of the quadratic function, you can say those are the solutions of the function. There's another word they use called roots. So if you ever see it say, find the roots of a quadratic function, they're saying the same thing. Find the solution. Find the zeros. They all mean the same thing. Find the zeros means find the solution. Find the solution means find the zeros. Okay? Zero product property. If at least one factor equals 0, in other words, if one of the numbers you're multiplying by is 0, then the product will be what? If I have 6 times 0, what's the product? 1? What's the product? 0. If I have negative 3 times 0, what's the product, Riley? 0. If I have 1/3 times 1, what's the product?
1/3.
1/3. I tried to trip you up. You have one of the factors has to be 0, and if one of the factors is 0, the product will always be 0. The product will always be 0. So no matter what you're multiplying by, if one of the factors of those 2 or 3 or 4, I don't care how many factors there are, if just one of them is 0, that makes the product 0. So here it is stated algebraically, because this is what's going to happen to us today. If you have a binomial and it equals 0, or another binomial and it is equal to 0, one or the other, they don't both have to be, just one of them has to be. If one of them equals 0, then when you multiply those binomials times each other, which we did back in chapter 7 also, we FOILed, we rectangled, we did it vertically, horizontally. When you multiply those binomials, if one of them is equal to 0, then what's their product going to be? It's going to be 0. If one of the factors is 0, the product will be 0. And that's going to be important to us for solving by factoring. Okay? So, here we go. Back to factoring. X squared plus 4x minus 21 equals 0. Let's change it to add the opposite first of all. And what's the first thing we identify? A, B, and C. A equals 1. B equals 4. C equals
Negative 21.
Negative 21. Okay. So the question is, can we factor this?
Yeah.
A is equal to 1. When A is equal to 1, what do we put upstairs in our diamond?
4.
Just no, what goes up here?
1.
Anybody remember?
Negative 21.
Right?
8 times C.
4 times negative 21.
No.
8 times C.
It's just the C, you guys. It's just the
I
C.
said negative 21.
Well, I'm sorry. There was so much, going on. I guess I didn't catch it.
Because
And so whatever is upstairs in our diamond, when A is equal to 1, we just have to put the C value there, because 1 times the C value will still be the C value, right? And what goes downstairs in our diamond, down here? The 4. So we are now looking for numbers that multiply to be negative 21 and add up to 4. Emerson, you got them?
3 and 7.
3 and 7, and one of them is going to have to be negative, right? Which one? The 3's got to be negative. Yeah. Negative 3 times 7 is negative 21. Negative 3 plus 7 is 4. Now remember, when a is equal to 1, that means we go right to saying both factors start with x. One of them ends with minus 3, the other one with plus 7. When a is equal to 1, we get to do that. That's the one that is pretty quick and easy. Okay, so it was factorable then, right? We found the factors. What are the factors?
Negative 3 and 7.
No. What are the factors for that trinomial? X squared plus 4x plus negative 21. What are the factors? Uh-oh, we didn't really learn what I had hoped we learned back in chapter 7. What are the factors of the quadratic? X squared plus 4x plus negative 21. In other words, what multiplied by what gets you back to that trinomial?
Negative 3 times 7.
Negative 3 times 7, what is that?
X minus 3 multiplied by
Yeah, we
x
gotta
plus
talk
7.
about the binomials. Those are the factors, you guys. X minus 3 is a factor. X plus 7 is a factor. So the factors are not negative 3 and 7. The factors are x minus 3 and x plus 7. Those two binomials are factors that if we multiply them together, we get back to our quadratic trinomial. So now that we have that, we take each of our factors and set them equal to 0 because, let's just do one. Let's just talk about one of them here. If I set that factor, x minus 3 equal to 0, and solve it for x, I would be finding the x value that would make that factor equal 0. Because remember what we just said at the beginning. If one of the factors is 0, what's the product of those factors? 0. And look at what we need it to be. We need it is set equal to 0. So we need, whatever we rename this as, we need it when you multiply it, you will get a 0. So what are we going to do here? Add 3. So x equals 3. What do you think we just found? We did find an x value. What do you think that x value is representing? Other than 3.
Where it would be on the graph.
Where would be on the graph? Where's it?
On the active, where it would be on the x-axis.
Where it would be crossing? Where it, the parabola, would be crossing the x-axis, right? Did we just find one of the zeros?
Yes.
Yeah, we did. We set it equal to 0. Did we just found one of the zeros. In other words, this makes that x minus 3 equals 0. Is 3 minus 3 0? What would happen if I put that 3 in here then? 3 minus 3, this would be 0, you just said. What would be 0 times that? I don't care what that is. What would 0 times that be?
0.
Would it be 0? So we just found one of the zeros. Because remember, this is like our y right here. So we just found one of the zeros. And notice, if we put 3 in here, because you got to put the same thing in both places. So 3 take away 3, you said is 0. What's 3 plus 7? 10. Well, what's 0 times 10? It's still 0. Who cares what it makes the other one 10? We don't care. We just care that it makes one of them 0. Okay, now let's do the other one. What if we want to make the other one 0?
Plus 7 plus 7.
We'd have to subtract 7 from both sides, and we get x equals
Negative 7.
negative 7. We just found the second 0. We just found the second 0. And when we find the zeros, we're really finding the solutions, aren't we? So again, let's just check this out. Let's go. What is 0 take away 3? I'm not 0. What is negative 7 take away 3? Go. Negative 7 take away 3. What's that? Negative 10. What's negative 7 plus 7? 0. What's negative 10 times 0? 0. So that one makes it equal to 0 also. So we're actually going to check them in the quadratic to make sure that it happens, but we just found the two places that parabola would cross the x-axis, the zeros of the function. Zeros of the function are also known as the solutions, okay? So would this parabola open up or open down?
Up.
This parabola would open up, it had a positive a value. So this parabola would open up, cross the x-axis at those two locations, at -7 and at +3. So its vertex has got to be down here somewhere in below the x-axis, doesn't it? Okay, let's check them out. So when x equals 3, that's our first, we think that's one of our solutions. So we're going to try it out and see if it works. So yes, you have to do this. 3 squared is 9. 4 times 3 is 12. And then we have that plus -21.
Y equals
9 plus 12 is
21.
21. Oh, now we're adding opposites. 21 plus -21? 0. Checks out. That's one of our solutions. And now let's check out our other one. We think that -7 is also a solution. Without graphing it, we believe that that is where it would cross the x-axis. So we put -7 in and check it out. -7 squared.
Y equals 49. Plus is 49.
This is 49. -7 squared is 49.
Plus -28.
And -28 is 4 times -7.
Also -21. -28 plus
That would be 49.
Doesn't matter which of these we add first.
No.
I like to add my negatives together first. So what's this?
49.
-49. So 49 plus -49.
Equals
We are adding opposites. That should be 0. That one checks out. So we can say x equals 3, x equals -7 are our solutions. Questions?
So it's gonna be like that.
Yep, you don't have to graph them today. Today you're finding them algebraically by factoring. But I still want you to have that visual of, hey, wait a minute now. This is what I would have found if I was graphing. I have no idea what the vertex is. This time I really don't care. But I do know I have a parabola opening up, and it's going to cross the x-axis where?
3.
At 3 and -7. Trey.
So you want us to find their opposites too then? Because at first we found out that it was 7, that x was +7, and then 3, we want to use the opposite too?
No, why would we do that?
No, like right here, this step. Step above that. and you just-
Back in this step up here?
Yeah,
This is what the step you're talking about?
yes.
You thinking that we now also would say that the opposite
No,
of
do
3 is
you
the
want
solution?
us to do that step too?
Yes, yes, we need to do this step. So we're going to factor. We have to set each factor equal to 0 to find out what they are, and then we were doing a check problem. Good question. We do need to do all of them. Factor, get the factor name, which is set equal to 0. Take each of those factors and set them equal to their own 0. Find the solutions, and then check your solutions. Okay, let's go to the back side then and practice again. So I got a couple of subtractions here to change to add the opposite. So then I can identify A, B, and C. A because I want to have a good idea of whether my parabola should open up or down. B and C because I need them for factoring. Okay, so A is
1,
B is,
-4,
C is.
-5.
Okay, thanks. You go ahead and try and get your factored name for that trinomial. That's all you're doing right now is you're getting that quadratic trinomial renamed in its factored name. So when you've got it renamed, look up and see if you agree with my factored name. After you've got it renamed. Because then what would be our next step after we do have it named? In its new name. It's still the same quadratic functions, they would still have the same graph, we've just renamed it. 3 plus 7 is 10, so is 2 plus 8. Both are at the same place on the number line, but they look different when you look at their expressions. So, what are we going to do next?
X minus 5
X minus 5 what?
equals 0.
X minus 5 equals 0, and what would be the other one?
X plus 1 equals 0.
X plus 1 equals 0. We have to do
Plus-
both of them.
Plus 5 plus 5.
So we'll add 5 to both sides of this one, and our solution, one of our zeros is
X equals 5.
5,
Minus 1 minus 1.
and subtract 1 from both sides, and our other solution is
Negative.
-1. So there are 2 zeros, there are 2 solutions, there are 2 places that parabola will cross the x-axis according to us. But we don't know for sure until we do what?
Check problem.
Check problem. Okay, so now we will check them. So we will check, and we'll do when x equals 5, and when x equals -1. Those are the 2 that we believe are solutions. So write down the quadratic as it was before you renamed it. Go back to how it started and substitute it into that, because that's where you need to make sure that the answer works. Because you could have factored it wrong, and we don't want to take that chance. I'm just working away. You can check to see if you agree with me when you're done. And some of you think you're so amazing that all you have to do is show a substitution step and then say 0 equals 0, and I'm supposed to believe that you really did it. No, we can't go right to 0 equals 0. We know it's supposed to end up that way, but we don't get to pretend it does, or fake it does, or not really verify that it does. You need to do the substitution step and then work your way down until you actually get a 0 like you should. Okay? So, anybody need to ask questions on this one? Okay, then our last one that we're going to do together is, remember, just like yesterday for graphing, and the day before for graphing, the equation had to be set equal to what?
0.
0. So is this one set equal to 0?
No.
No, so what are we going to do to get it set equal to 0?
Plus 9.
Okay, now, hear me on this, everybody. Eyes up, ears open, you need to hear me on this to save you hassle. When you are getting the equation rearranged so that it is set equal to 0, you want to have a positive a value. Try to have a positive a value. You do not want to not treat a -1a the same as you can a positive 1a. You cannot treat them the same. So always rearrange it so you'll have that a being a positive 1, not a negative 1, okay? So even though maybe, if it looks convenient, you only have to move one thing doing it one way, and instead of 2, do it so that the a is going to equal positive 1. And you guys told me to add 9. I'm feeling good about that because I'm going to still keep my positive 1 squared.
Do you want them to write that on their notes?
That would be a good thing to
That they
write
should
down.
have a positive a value?
Yeah. Move, let's do that. Move what will keep or make a, oopsie, I didn't mean to put that equal sign there yet, make a equal 1. We don't want a negative 1, we want a positive 1. So we'll just create more, we'll start maybe doing some things wrong, because we'll think we can treat it the same way as we can with a positive 1, and we can't. Okay, so now we have our quadratic function set equal to 0 like we need it. So x squared plus negative 6x plus 9 equals 0. Our a is positive 1, that's good. Our b is negative 6, and our c is 9. So in our diamond, what do we need up?
Negative 9.
9. What do we need down?
Negative 6.
Negative 6. Brighton, what are the numbers that multiply to be positive 9 add up to negative 6? Negative 3, negative 3. So now we can say, here's the factored name replacing the trinomial name set equal to 0. What is it?
X minus 3.
X minus 3 times x minus 3.
Do you want us to do the adding step for both of them?
What do you think, Claude? You think it's going to be useful to do the adding step for both of them? What's going to happen if we set both factors equal to 0? So in other words, if I take x minus 3 and set it equal to 0, and I take x minus 3 and set it equal to 0, and I solve both of them, what's going to happen?
They're both going to be equal.
They're both going to be 3, aren't they? So when the factors match, when they are exactly the same, you do not need to worry about doing it twice, because what is the situation here? Tell me what the graph would show here.
The vertex is going to be on the x-axis.
The vertex is going to be on the x-axis. The vertex is the 0. There's only one 0. There's only one solution. This is one of those graphs where the vertex is sitting on the x-axis. So we only have this one solution. So how many solutions do we have to check out?
1.
Only one. If there's only one 0, only one solution, we only need to check when x equals 3. So here's our solution right here. One solution, 1, 0. This is a parabola opening up on the x-axis right here, like that. Okay, let's write down our x squared minus 6x equals negative 9. Let's put it in. Let's go put it back into that one. Let's see if it.
If we put it into our modified one, will we get the same answer?
Well, you should, but it's always a good idea to make sure that you modified it correctly. So that's why it's a good idea to check it in this one and see if it makes it true. It's not going to get equal to 0 this time. This time we'll just make it true. Okay, so let's put in 3 and square it. And plus a negative 6 times 3, and we're supposed to get negative 9. So we get 9 for 3 squared. What's negative 6 times 3?
Negative 18.
Negative 18. Over here, we still have more to do. What's 9 plus negative 18? Negative 9. Because we want it to be, or because it really is? Because it really is. Okay. So in this case, remember what I said. It's not going to be 0 equals 0. It's going to be, but we still end up with a true statement, don't we? So it checks out. Because sometimes you can rearrange them incorrectly, and then you think it's going to work because it worked in your rearranged one. Okay, right.
Can't we add the negative 9, like put plus 9 plus 9 and have it equal 0?
You can, but I'm just saying that you might not have as good of a check because you might have made the wrong decision how to get it set equal to 0. But you can check it out in that way, in the set equal to 0 way instead. Isaac?
I was going to say, because my math is positive.
That's fine. Okay, so, well,